Here are the answers for the section 5-2 homework. We're asked to write the expressions as rational expressions. That means as ratios with a numerator and a denominator. And then we have to figure out any undefined values of the variable. So in question number 1, 3 divided by x, we would write as 3 over x. This makes it look like a rational expression. To figure out undefined values, we look in the denominator. In math, a denominator cannot be 0. So we want to say that x cannot equal 0. This gives our undefined value of the variable, the number that is not in the domain for x. In number 3, the decimal 0.7 is the same as 7/10. So we can write this as 7x over 10. This time there is no variable in the denominator, so there are no undefined values of the variable. Number 5, the factor that has the negative exponent can be written in the denominator, using our rule about negative exponents, which is that they mean reciprocals. So the t to the negative 1 exponent can be put down into the bottom, where it will now have a positive 1 exponent. There is a variable in the denominator. That variable cannot equal 0. That's our undefined value. Number 9, we have 5 divided by something. So let's write that as a ratio, 5 over 7k plus 14. There is a variable in the denominator. The denominator cannot be 0. So what value of k would make the denominator be 0? To figure that out, let's write 7k plus 14 and indicate we do not want that to turn out to be 0. Now solve this like it was an equation. Subtract 14 from both sides. We find out that 7k cannot equal negative 14. Then divide by 7. We get k cannot equal negative 2. That's our undefined value. K can be anything except negative 2. Now number 13, we already have the numerator and denominator, but what we can do on this one is factor these and then cancel any common factors in top and bottom. So looking in the numerator, we can factor out a GCF of 5, getting x plus 3. In the denominator, we can factor the trinomial using FOIL. So 2 sets of parentheses. X times x is the x squared. Negative 3 times positive 1 makes the negative 3, and they add together to the negative 2. Well, why did we do that? It's so that we could reduce any common factors and so that we could identify any undefined values. We do have variables in the denominator. What values of x would make these turn out to be 0? Let's find out. We don't want the x minus 3 to equal to 0, or we don't want the x plus 1 to equal to 0, and solve both of these like they were equations. This becomes x cannot equal 3, or x cannot equal negative 1. Number 15, the negative exponent means a reciprocal. So we can write this as v minus 4 over, and then put the v squared minus 4 in the denominator. But v squared minus 4 can be factored. So we have v minus 4 on top, and then in the bottom, 2 sets of parentheses. X plus 2 times x minus 2. If there were any common factors top and bottom, we would cancel them away. That's called reducing. But there aren't. However, factoring the denominator helps us to get those undefined values. The x plus 2 cannot be 0, and the x minus 2 cannot be 0. Solve both of these like they were equations. X cannot equal negative 2, or x cannot equal positive 2. Number 17, let's factor the denominator. It is a difference of squares. So we have our z minus 1 on top, and then in the denominator, z plus 1 times z minus 1. There is a like factor, top and bottom, which will cancel away with slash marks. Before we do that, let's take those factors and figure out our restricted values for z. The z plus 1 cannot be 0, and the z minus 1 cannot be 0. So z cannot equal negative 1, and z cannot equal positive 1. The other thing that we can do is to cancel our common factor top and bottom, leaving a 1. And so this is equal to 1 over z plus 1. For the review, we're going back to page 160, where we are practicing our exponent rules. We're multiplying and we have the same base. So you write the base and add the exponents. For number 9, the same situation. We're multiplying variables. So you write the variable and add the exponents. 2m plus m is an exponent of 3m. Number 15, we have a division problem. So you write the base and subtract the exponents. This makes a to the 7th power. Number 27, let's distribute this exponent to both of the factors in the parentheses, starting with the letter c. Negative 3 times negative 4 makes 12 as an exponent. Now the letter b. Negative 1 times negative 4 makes a 4 as an exponent. Number 29. Anything to the 0 power is equal to 1, except 0 to the 0 power. So the answer is 1 as long as x is not a 0. Number 45. The only thing we need to do is fix the negative exponent part. So the r squared stays where it is in the top, and the t to the negative 2 gets moved into the bottom and becomes t to the positive 2. The directions don't say that we have to tell what the undefined values are, but because of today's topic, we know that the t cannot be a 0. On page 161 written, it's the same directions. Let's simplify these. Working in the parentheses first, we get negative 6, and that's raised to the negative 3 power. A negative exponent means reciprocal. So this is 1 over negative 6, and now it's raised to the positive 3 power. 1 to the 3rd power is 1, and negative 6 to the 3rd power is negative 216. So our answer is negative 1 over 216. Number 11, let's do some work in the parentheses first. What's the 121 to the 0 power make? Any number except 0 to the 0 power makes a 1. And now we have our times 5 to the negative 2. And that's being raised to the negative 2. Multiplying by 1 doesn't really do anything, so this is just 5 to the negative 2 raised to the negative 2. Let's use the rule about taking a power and multiplying by the other power. We get 5 to the 4th. You can leave it like this or evaluate what 5 to the 4th power is equal to. Number 13, we want to take the number 2.45 and times it by 10 to the negative 1 power. Timesing by 10 to the negative 1 is like dividing by a 10. So if you divide this by 10, the decimal point goes one spot to the left, and you'd get 0.245. Number 21. Let's use our rule about subtracting exponents to do this division problem. Start with the letter P. Negative 4 subtract 1 is a negative 5. Now the letter Q. 5 subtract negative 2 is a 7. Now the letter R. Negative 6 subtract 3 is negative 9. Now let's use our rule about the meaning of negative exponents to make some reciprocals. Please notice that the letter Q goes to a positive exponent, so it will stay in the top. But the ones that had negative exponents will move into the bottom. We'll get P to the positive 5 in the bottom and R to the positive 9 in the bottom. So the answer is Q to the 7 over P to the 5th, R to the 9th.